Should we make this async? It's one of the questions that seems simple, but can make a huge difference in the long run. If you get it wrong, you'll spend months fixing the mess. How to decide? You should not just guess. I am yours.
And I'm Robert, and this is No Silver Bullet Life podcast, where we discuss mindful backend engineering. We spent almost 20 years working together across different projects and teams. Learn that following advice like always do X or never do Y doesn't work and can limit your growth. In this show, we share multiple perspectives that will help you to make smart choices and grow you into principal engineer level.
And if you have any follow-up questions, you can leave them in the chat. We can pick them up during the discussion if they are relevant, or otherwise we will have a Q&A session at the end. So we will go through all the questions then.
Yeah, and to be on the same page, so today we'll discuss async in context of architecture, not async in context of your code. So we'll not discuss threads, we'll not discuss Go routines, we're not discussing code level async. We'll discuss the higher level architecture, so related to pub subs, queues, and similar systems.
Yeah, maybe the context would be we have two services, microservices or programs in general, two or more, and we want them to talk to each other over the network in some way. That's what we want to focus on today. And usually it works like one of the services asks for something, makes a request, and then waits for the result. And you have to handle the error in some way if it happens, or basically check the status code, which is the main difference between sync and async. And yeah, maybe one specific case is where you fire and forget. So you make the request and then you don't care about what happens later in the other service. But I think we can agree not to talk about this case today, because it's pretty rare that you don't care about what happened on the other end. If you lose the status code, the response, you don't know if we can continue or should you let the user know what happened. So let's keep this one for now.
Yeah, so if you are talking about synchronous architecture, so as contrast, so in most cases we are talking about gRPC, HTTP architecture. So in other words, you're calling from one place, you're calling one service, and within the request context, some operation is done. So maybe some database, something is written to the database, maybe some transaction is done, maybe some money is moved or something like that. So basically,
transferred to another account. Something happens in the other service.
Yeah, and basically, you know that if this request returned you some 200 like the HTTP code or gRPC status code that it succeeded, you know that it succeeded. But and it's nice because it's the typical architecture that we are building. So if you are learning how to code, usually you are using synchronous architecture. You are not using event-driven architecture or message broker, because it's probably something more complex for somebody who is learning. I guess, Miłosz, when you were learning how to code, you started with building some synchronous APIs, probably.
Yeah, I started with no APIs at the very beginning.
When we were learning programming, there were no APIs yet.
I didn't learn microservices first, but it's for sure first method of communication you can see while learning. It's probably the most natural. So that's one of the upsides of using synchronous architecture, that it's quite predictable in the flow. It's kind of like the method call goes over the network, and when you read the code, you don't really need to know what happens underneath. I think there are some frameworks that try to do it for you, even that you can distinguish between, like the RPC calls basically look like normal function calls. That's a separate topic, but the point is that's one like good thing about Sync, that it's pretty easy to understand what's going on in your function.
And it's natural for you, so the entry point for that it's much smaller.
Yeah, if even error happens or exception is thrown or whatever, it will exit the function just like any other function call. That's one of the pros.
And yeah, as if you were working as software engineer for longer, as also you may prefer simple approaches, because simple approach doesn't require any additional complexity. But, well, as usual, it doesn't cover all the possible use cases. So unfortunately, there are some cases when the simple approach of synchronous communication is not enough. So, for example, you are calling some external service, it can be other team, it can be other company, and for some reason this is working slowly or even doesn't work. It's not the best situation, but, well, this is where we are often. So we need to call some other team services or some external services, and doing it synchronously sometimes may be hard. So I remember when we were working with some, for example, invoicing software that was outsourced, and it was sometimes working, sometimes doesn't work, but we were not able to change that because it was some contract and we would have been obligated to use that. Well,
maybe even an external API completely out of your company. That's some third-party service you use, and you need to use it, but you can't just you have to deal with the API, whatever it takes.
Yeah. And sometimes, for example, also some real world examples. So sometimes you may be integrated with some external marketing systems, and for some unknown reason that I don't know why, but often those systems are not that stable. And sometimes it's part of a customer registration flow, but from some other side, you need to send some data when you're registering customer. And, well, you cannot risk that basically it will break customer registration flow because it's part of the critical flow. So it's also pretty problematic, and in synchronous way, it will be hard to handle.
Yeah, it's one of the limits, I think. And it's often a question people ask us about designing the architecture. So they recognize that they have a database transaction that does something like saves the user, let's say, in the database, and does a few other things. And they also need to call this, let's say, marketing software via API. And they are confused how to model it because the API call should it be inside the transaction? Should it be outside the transaction? How to do it? And basically, there's no good way to handle this in the synchronous approach way.
Yeah, you can choose basically what's less important. For example, okay, we've failed to send some marketing information, integration to some marketing system. Well, or maybe it's something critical and maybe we should interrupt our registration flow. It depends, unfortunately. But, well, when you're doing it in synchronous way, you need to do those trade-offs.
Yeah, the worst case here is when you ignore the issue. Like you assume, okay, but database commit never fails.
Or the system will always work.
Yeah, and might be true most of the time, but usually if something can happen, it will happen on production sooner or later. And what I really don't like about ignoring this challenge is that you end up with inconsistency in the system. And fixing this is super hard. First of all, you need to figure out you have an inconsistency. And if you have no proper monitoring in place, you might never know. You can see it weeks later or months later.
Or even worse, let's imagine that, okay, something on the other side, we assume that, okay, it's stable, it's always working, this external system of other company, and you have some big promotion, big marketing, and you have hundreds of people trying to register, and the system is down. And I guess that a lot of people may be pretty upset because somebody spent some horrible amount of money on marketing, preparing that. And because of this assumption, it's not working. And often, it's important integration that if you disable it, you'll find out that, okay, it's hard to track what's happening with customers, and it's super big problem for everybody.
Yeah, so it can easily become a bottleneck.
Yeah. And if you are talking about bottlenecks, so other problem that often you have with synchronous architecture is problem with scalability. So often you have some operations that are heavy and they are working fine when you don't have super big traffic, but hopefully your product that you're working on at some point may have some bigger spikes of traffic and you may have more customers. And if it's not designed in a proper way and it's just done everything asynchronously, at some point people will just start to see errors because the operations that they are trying to do cannot be done because you just don't have enough resources. And if you're doing it synchronously, you cannot do much about that if it's critical part of the functionality.
And the bigger the system, the worse it becomes. For example, if many services depend on this one, which is a bottleneck, it can kill your entire platform.
Yeah, and I've seen that many systems are trying to do some workarounds for that, like cron jobs or even worse, database triggers. And okay, it's some kind of workaround for that, but from our experience, it doesn't scale at the end, and not only in terms of resources, but also in terms of maintenance, and it's mess at some point of complexity, basically.
So the other approach is asynchronous architecture, and we talk about we don't talk about the code level. So stuff like callbacks or promises or the actor model, whatever you use in your code, it's out of scope for now. Coming back to the context of two services that talk to each other, I would say that the goal of asynchronous architecture in this context is that we want to execute this in the background, this request, whatever it is, but also we don't want to lose the information about the result. And even if the result is empty, maybe there is no payload, but the status message or the fact if an error happened or not is an important fact. So we want to handle it sometime in the future, but we don't want to wait for it to complete in the current function.
And again, some poor man's approach may be putting it to the table and doing some batch jobs, but while it can work, it's not perfect approach because at some point, if you have more jobs to process, you may end up with just it taking more time than the entire day have. So parallelizing of that may be a challenge. And it's often also delaying when it's processed, basically.
Yeah. So Gabriel mentioned in the chat that it's easier to debug. I think this was about synchronous approach. Yeah, that's a super important point. That if you have a classical function that goes one after the other of the steps, it's quite easy to understand what's wrong and debug. With async, it's a bit more complicated. We'll get into that. So what solutions do we have in terms of the architecture? Well, I think maybe what many people may be familiar with is task queues, which is usually a simple FIFO, first in, first out queue of tasks that some worker processes pick up from. And it's pretty easy solution and can work well for simple use cases when you just want something to be done in the background and forget about it. The downside might be that if you have a more complex setup, it's probably not enough to handle it well, but it can work.
Yeah, so the two cases that I would have in mind when queues may be not helpful compared to some, for example, event-driven architecture is case when you have more teams. So it doesn't help you with, let's say, organizational scalability. So basically, you have one queue, and it's kind of similar to sharing database. So if multiple teams are sending messages to queue and one message is spinning, it's blocking other teams. So it's not best experience. And the second thing is that if it's order queue, even if you have multiple queues and you have some high priority or low priority queues, it's also pretty limited in terms of performance.
Yeah, but for a simpler architecture, it might be a pretty good solution.
Yep.
For sure, better than just hoping it won't break in a synchronous way. But a step forward in this are messages in general, and often using a message broker in the middle, like or a PubSub. So this is a similar approach, but instead of having workers pulling tasks and doing one thing, we connect the services using messages. And there's usually many ways you can build this topology, like who receives the message, and it depends also on the infrastructure you use. You might be familiar with message brokers like RabbitMQ or Kafka or the cloud-based ones, and they all have a bit different configuration. But the point is, it allows you to communicate between processes using those messages.
Yeah, and what's the key difference here is the fact that when you're publishing some message, you basically don't care how it will be processed, by whom it will be processed. You basically emit something, usually event, and this event can be processed, maybe not processed, it may be spinning for a while, you don't care. And it's nice because it's decoupling you from the consumers. And it's adding the thing that I mentioned in terms of queues, that it's not handled by queues. So it's creating some kind of way that helps with scaling multiple teams. So if you're decoupled from consumers of your teams, you basically tens of, even hundreds of teams can listen to your events, and you don't care if it will fail or not.
So this is if you use events, right? So an event is kind of a message, and it states a fact that happened already. So this is a big, I think, more like mindset shift rather than technical thing.
Mm-hmm.
Because you can easily use messages, but if you send, for example, requests like in RPC just over messages, it doesn't give you the same decoupling benefits.
Yeah, and
right?
I think it's nicely how it works out of the box with events. I mean, how it fits this model nicely, because so events is information about the fact that happened. So it's not something that will happen, maybe happen. No, it's information about something happened, and it cannot fail because it already happened. So you cannot say, oh, no, it didn't happen. It happened, and it's nice because it's in some way immutable. So everybody can listen to that. They cannot say it didn't happen.
Yeah,
and
they can't not agree. It didn't. Yeah, I think it simplifies the design often, right? Because let's say you have this process after, I don't know, someone placing an order, and instead of this one process figuring out 10 other things that need to happen in the entire system, like send a receipt, send an email, notify the sales team, whatever. There can be many triggers like that.
Yeah, and
you can just send a single order placed event from this system, and then other systems react to this.
Yeah, and we'll go to anti-patterns a bit later, but I think one of very often seen anti-pattern is passive-aggressive events anti-pattern. So usually when you are creating an event, it should be verb in past tense, so order placed. But it shouldn't be event like order should be placed.
Yeah.
Because in this case, it's more like a command, and commands are more fitting the queue system. So you're sending this queue, and one consumer is subscribing to that, and okay, maybe order will be placed, but maybe it will be not placed because you don't have enough items in an inventory, for example.
It's a funny thing because it's mostly about naming things. There's nothing much different about an event than a regular message. The difference is just the payload and how you call it. But if you pick the right names, the design becomes much more easier to follow.
Yeah, and that I think is interesting because many people are looking on that like, naming doesn't matter, whatever, name it X, Y, Z, and it will be fine. But I will not agree after seeing how it can help or it cannot help if it's not properly designed. So.
Yeah, it's about mental load pretty much, how easy it is to understand the design. And then it's also easier to debug issues or extend it if you need.
Yeah, and I remember that some people asked about that in Watermill, so the library that we're maintaining in Go. And what's the difference between command and event? Because basically API is very similar, but there are some really small reasons. And yeah, basically you can send command as event, but again, it's just practical to follow this because it will be easier later.
So maybe let's come back a bit to messages in general, not just events. And I think one thing that's pretty different in how you approach in asynchronous way is error handling.
Yeah, and I think it's cool. It's cool thing out of the that you get out of the box. We can say with event-driven or many asynchronous approaches that is basing on message broker. Because if you are doing operations in the background, so for example, instead of emitting event or sending some message, when you are just doing it within a process, you never know if this process will not die. Because, for example, Kubernetes will say, you should be dead. You never know. It can happen. And I know that in some smaller systems that are not mission critical, it doesn't matter. You will lose some operation. Maybe somebody from operations team will be upset, but that's it. But if you're building some systems when this consistency really matters, and I would say that in most cases it is, if you are not storing things that you would like to process in message broker, in some cases it will just happen that your process will die and some operation will be not processed. And when you're sending this event or message to your message broker, it's up to the message broker to ensure that it's processed, and only if you will confirm that it was processed, the message will be deleted. And it's especially useful when you have some temporal outage. So let's imagine that some external API was down for a couple of minutes, your database was down for a couple of minutes. In this case, when you are subscribing to the messages in message broker, it's not an issue. So messages will accumulate over the time, and it will just auto-resolve after the time. And I think it's pretty cool when we work with some systems when we've seen that, okay, some outages of external systems was happening, but it was not a big deal. So we sometimes received non-critical alert like, oh, we have some messages that are stuck, but it was just stuck for a couple minutes, and later you can see how the chart is going down. Always pretty possible to see that.
It can also be a bug in your code. You can mess something up, and then the requests fail. So in synchronous approach, all services calling your service, this broken service, don't have much choice what to do. Like the best they can do is probably return the error up the stack to the previous caller, and then up to the user, show on the UI, right? But if you use messages for this, then yeah, this thing won't be done in the moment, but then you can deploy a fix for the code issue, and as you said, all the messages can be processed again.
Yeah.
So the auto healing is pretty cool to have, and I think it's also another factor that simplifies the mental model. because you don't need to care about error handling in each scenario. How to do it, how to make this nice for the user to report or just get over with. Instead, you know that you can just retry, and most of the time it will work fine.
Yeah, and another similar situation is when you are receiving bigger traffic because of many reasons. So many people went to your website, or you have some attacks sometimes. It's also kind of similar situation because normally you would not be able to process all those requests, but if you just receive a lot of messages, you can accumulate them and process them in order that you can have. And it's also helping you to scale it with that, because if you have some way of auto-scaling your application, you can basically configure it in multiple ways. But when this autoscaler will detect that you are using a lot of CPUs or there are more messages to be processed, you can just autoscale more, process those messages, and downscale your application back. And it's kind of almost out of the box, we can say.
Yeah, not always ideal. Depends if you need this thing done right away or not. But if you can wait a while, and it's much simpler than scaling up to handle all incoming requests.
Yeah, and again, I think many people are mentioning event-driven or in general asynchronous architectures in terms of, let's say, technical and performance scalability, but we have also the perspective of organizational scalability. So you can basically integrate more teams over events, and thanks to the decoupling, you can add more teams and they can just work more independently.
If you design them well. That's a prerequisite.
Obviously.
Because there are also lots of downsides of asynchronous architecture, or maybe not downsides, but challenges you need to be aware of, right? Like what we mentioned a couple of times already, that the design is important. So that's one thing. It's more complex in general. And you need to understand the rules well. Ideally, the entire team would be familiar with how the stuff works. So the more experienced team, the better for this kind of architecture.
Yeah, but as usual, so you have more complex problems to solve. It's better to have more experienced team to handle that.
Yeah, because for some platforms, you can just use only synchronous approach and be done with it. So at some point, you just need to move to at least parts of async. And there's lots of new issues you need to deal with, like eventual consistency or race conditions or debugging, for example. Local development can be a bit more complex. You need new infrastructure, the message broker, which also is something the team needs to be familiar with and you need to maintain.
Yeah, also testing is a bit more challenging because it's no longer working like you're doing HTTP request and after request is done, you know that operation is done. No longer. You need to do some way of polling. So if you worked with front-end a bit, so it will be familiar for you because like in front-end, things are not that synchronous and sometimes you need to just poll for some operation that you expect that will happen, and yeah, it will eventually happen, but maybe it will not.
Yes, but speaking of front-end, the UI also needs to be adjusted sometimes.
Yeah, and I think even Gabriel mentioned that it can be more difficult to handle errors in UI in async system. So you need to either use WebSocket or servers and events to push async errors, like in case of failed sync operation. Yeah, we totally agree that this is the challenging part. And
exactly, yeah, this is it. So with synchronous approach, you can just return the error up the stack until the UI, and then just show a big 500 error and something like try again or contact our support. With async approaches, the error is there somewhere in the system, and the user doesn't know it. If something happened or not, it was successful or not.
Yeah.
So this extra setup to show the status asynchronously.
Yeah. So in other words, trade-offs, because it really depends on basically what the system is doing under the hood. Because again, if you are storing stuff to the database and it's your database and it's stable, it probably wouldn't be a problem. But if you're doing some stuff in the background, it's starting to be tricky. And it's also easy to create a poor UX design that will be just misleading for people that are using that.
Which is also counterintuitive, because it seems like something specific to backend. And here you need to consider it in the entire flow, even in the UI.
Yeah, and again, the thing that Gabriel mentioned, so we are also big advocates of servers and events. If you're interested how to implement it properly in Go, so we have a pretty nice article about that Miłosz wrote on our blog with super nice example. So we'll link it in the podcast materials if you are interested.
Okay, any other downsides? What about observability?
Yeah, it's also a bit tough topic, because when you are building your REST API, you can basically monitor your HTTP load balancer.
You can open the console in the browser, and most of the time you will see some error, where it happened.
Yeah, or just check your load balancer and you have 500s on your load balancer. You see that, okay, something is wrong. We need to do about that. With asynchronous approach, well, it's not that easy, because probably you should monitor how long is the queue, what is the age of oldest message. It's also not simple, because it depends on queue or topic or subscription. Like sometimes having event that is there or queue for 5 minutes, it's fine. But sometimes if it's delayed 30 seconds, it's maybe a problem. Sometimes having 10 messages spinning is fine. Sometimes it may be critical issue. So I'm not saying that it's not possible to implement, but it requires more thinking, and it requires more of what you said at the beginning, that you need to spend a lot of time on designing and understanding. Okay, maybe not in a lot of time, but basically you need to have it in the back of your head.
Have some tooling in place, like tracing, at least, to see what's going on, to understand what's where the issue is.
Yeah, and some metrics that I know that not every team have, but in this kind of architecture, you should have that. And I know that also not all message brokers is exposing the metrics about, for example, oldest message or how many of messages is spinning. So sometimes, unfortunately, you need to write it by hand and export it by hand. So obviously, it's some cost. For other side, it's also not unsolved problem. I mean, it's solved problem if you just know how. If you find the well-known solution for that, it's not rocket science at the end of the day. Mm-hmm. But it's just important to keep it in mind, and keep in mind that every operation is also different. And there's also one challenge that I think not a lot of people are mentioning, but because it may be a bit counterintuitive, but it's problem of decoupling. And why it's interesting, because usually we're talking about decoupling in context of good thing, but also decoupling may be challenging when it's, let's say, extreme decoupling. So, like with events. So let's imagine that you're emitting some event, like order was placed, and you may have no idea actually who is listening to this event. So when you have your API, you basically see that somebody is calling this API. You probably can have some tracing and by that correlate from where it comes. But if somebody is listening to your event and the service doesn't have good observability, you have no way to understand who is doing that. In worst case, even you have no idea if anybody is doing that. And it's starting to be problematic when you need to change something. We'll get into that, but it may be challenging, especially if you have bigger system with more teams. it may take months to deprecate some event.
Yeah, you want to get rid of some code that produces some old event, but you don't know if any team is using it. So that can be in larger organizations that can be challenging.
So in other words, decoupling is not always good. But I think it's also similar like with don't repeat yourself. So often don't you repeat yourself may be a good idea, but not always. And it's a similar situation because don't repeat yourself, it's trying to kill decoupling. Try to kill coupling. But also if you go into extreme, it may be problematic. So it's, I think, interesting how you can apply some patterns and anti-patterns from level of code to level of architecture in some way.
Yeah, because you may promote teams that are very focused on what they do, and they just publish some events, and then they don't care about whoever is doing with those events. Yeah, it's harder to see than with API calls. I think that there are some tools for this. I'm not sure if we used any of them, but probably also depends on the approach you take, because there's no one standard for how to define events. I mean, there are some, but probably depends on the company and message broker and technology use.
Yeah, but I think you reminded me about this case, and it's pretty interesting that I remember in one place we had an event that we're integrating. We have integration between two teams, but yeah, indeed we have some data quality issues there. And what we ended at the end was getting rid of this event and instead having a synchronous endpoint that the other team needed to call, and we was able to basically do validation of the data.
Oh, that's interesting.
Yeah, and in this case, I would say that this extreme decoupling was bad because, again, there was problem of responsibility because somebody could emit an event that have totally no, it was totally not valid, and it was hard to enforce because if this event was emitted, we've been notifying it after a while in our systems that we are starting to receive some events. It was like, oh, we don't care. We
did our job. We published the event. What do you want? Yeah, that's interesting thing. It's like on the boundaries of team when you integrate to teams, to services that belong to different teams, the API becomes super important. And yeah, maybe sometimes Synchronous is better in this case.
Yep.
Yeah, that's a good take. Let's move to common anti-patterns.
So you say that it's not perfect and it has some pitfalls and something can go wrong with asynchronous architectures.
Looks like there's no silver bullet. So I would start with two naive takes on background processing. So I've heard of systems or seen some where people use something like a cron job to process the background tasks. It's similar to task queue, but more like in-house. And again, similar to task queue, it can probably work well for some cases, except you reinvent the wheel in this case, so it's a bit worse, I would say. And the main issue is if you have any more complex scenario than simple, please do this later, then it breaks. It won't help you much. And you don't get all those guarantees of pub/subs and so on.
And it's also often processed at some magic hour, so it's creating delay, basically. So if you're doing batch processing with your cron job.
Yeah.
But I would even say that it's still better than database triggers because, I mean, it's choosing between two evils, but at least I would say that it's probably a bit easier to maintain.
Yeah. Yeah, logic in the database is a controversial topic. I wouldn't want to work with a system that does it. And of course, there is probably this, one specific case where it makes sense. I'm sure there is, but in general, it's tough to update and manage this. So I would rather
test and debug.
Yeah, if I had to use a cron job like this, I would just do it in the code. And for example, in Go, it's trivial to spawn a new Go routine. So that's a perfect scenario. Just have an infinite loop with a sleep and do something every, I don't know, minute or something.
And it can be some good starting points, and that you can migrate a bit later to more proper solution.
Yeah, my main issue with this is that you reinvent something that has been solved, and many people, put years of work into figuring out the edge cases and everything. So maybe it's better to do something that exists.
Especially that, for example, with Watermill in Go, you can pretty easily use Postgres or MySQL as pops up. So basically, you don't need to add an extra architecture there. And you can start with something simple and without many changes, change it to some real pops up later. So I would say, I know that it's not available in all languages, but in general, it may be also some nice starting point. And it's just less to migrate later when it will be start to be problematic.
There is one worse kind of cron I've heard about, is that you write a cron to check for inconsistencies in the system.
Oh no!
So let's take this example of calling this marketing API after a user signs up. So you realize this can sometimes fail, and you write a cron job that does a check between the database and the marketing API and see if anything is missing.
And basically, you need to implement everything twice.
Yeah, and my worst worry here is that you kind of promote ignoring issues. And whatever happens, whatever issue like this you have in the future, a challenge like that, you will just write another consistency check. And this is another code you have to maintain. And basically you just sweep the issue under the rug instead of fixing the root cause. So yeah, I think that's too naive take to work in a large scale system.
But I can remind one case when it makes sense, but I would say it's rather exception. So when you are working with some, let's say, critical systems that you are quite sure that everything is fine, but you would like to do some double check.
Sure. Yeah, I mean, checks in general, consistency checks in general, I wouldn't say that are a bad thing, but if you are doing them because you can design a better API, that's the issue.
Yeah,
you anticipate them to happen. I would create a consistency check in places where I'm sure they won't happen, but I want to be extra careful anyway because it's some critical.
I think the big difference is if you are implementing some compensating operation in this checking part. For example, if you are working in some financial system, so it's typical to do some reconciliation reports in some interval, but it's making report. It's not doing the compensating operations. I mean, your logic should be valid, and you should just do validation at the end to ensure. But again, it's just for critical systems that you need to be sure. Like, for example, if to your company or whatever, $100 came in, $100 should come at the end. But again, it's not about doing compensation. It's all about double checking the logic that you have.
Right. Especially if you have, if you have a few of those in the most critical areas, that should be fine. But if in every API call you need to do this check and compensating logic, then it won't be maintainable after a while. You will go crazy just trying to cover all use cases, and then any API change or whatever will also break this, so you have more code to maintain. Again, I would fix the root cause if you know it can happen.
Agreed.
And one more regarding this naive approach is when you use messaging and you use kind of events, like you said, those passive aggressive events, or just something that's more like technical, not in the domain or business sense. It can seem like smart design, but it's not always the case. It doesn't automatically give you good results. I worked once with a system where there were two applications, like an old one and a new one, and they shared some entities. And there was a system that, for every change in the entity, published an event that it changed, that the other system consumed that and updated the entity, and the other way around as well. So, if a naive setup like this, you ignore many edge cases that can happen. And there are some variants on the entities, they have some rules, but if you just do a naive update like this, even if it's asynchronous, it doesn't give you anything, and it can be even worse because there can be some inconsistencies and you won't even know, because maybe some message arrives out of order or is like overwritten by the other one. So this comes back again to the event design topic, right? This needs to be like proper design. You need to spend some time and understand what you are doing.
Yeah, and I think it's probably time to give a big shout to event storming. That was usually pretty useful for designing some event-driven systems, but not only, because it may be also suggesting that event storming is for designing event-driven architectures or async architectures, but it's not. I mean, event storming is good for basically designing any kind of system, but it's pretty useful that you have notation that can be mapped to your software very directly. So I recommend it to check event storming. If you're looking for some materials how to do that, there is a ebook that is probably unfinished for last 5 or 10 years, but no worries.
It's great anyway.
I think 5 or 10 years or earlier it was already very good. So Alberto, really good job. Okay, another downside of or trap related to asynchronous architectures is creating distributed monoliths, because like many useful techniques, they are helping with many things, but often they're also opening gate of hell.
It's the new normal. Instead of monoliths, we have distributed monoliths.
Let's wait for distributed monorepos.
Yeah, we've seen it too many times.
Yeah, but the usual scenario is like, okay, microservices are great, we need to be scalable and etc., etc. And team is starting to build microservices, and you start to have more microservices than people. And at some point you notice that communication between them is hard, because if one microservice in the middle will not work for a while because our Kubernetes cluster is not that stable yet, all our requests in the platform are failing because of cascading failures, we need to do something about that. And unfortunately, often reversing decision of going into microservices is not on the plate, because, come on.
Too late for that.
Yeah, we invested that much in many stuff that we don't need. So often the solution is, well, let's use event-driven architecture. And, well, it's making all the problems that the team had earlier, it's making it deeper and deeper, because debugging everything is harder, understanding everything is harder, everything works slower. Okay, the one upside may be that, okay, at least it's kind of more stable, with caveat that usually there is the thing that Gabriel mentioned about UX, that, well, if something is processing in the background, it's a bit harder to show it in the UI. So compared to showing error directly to user like earlier, now something is happening and user have no idea what is happening. And yeah, it's pretty problematic thing that we've seen many times. So it's important to know that asynchronous architecture can solve, in this case, some problems. But again, don't be afraid to do the thing that we like to recommend, and we've did it multiple times, and it's the microserviceation. So basically getting your services and making less services. Again, having more microservices than people in a team, it's terrible.
But the interesting part about this pattern or anti-pattern is that it comes from good intentions. Like it starts with this idea that we have a small team now, but we will grow, and we need to be able to separate some code easily, right? And then you have those separate services, and you figure out, okay, let's now just connect them like we did with function calls before, and then it breaks. But it comes with this good intention of separating the concerns.
Oh, I think it's problematic with good intentions, because I think all the bad systems that we worked with was built on the good intentions. Because, it's rarely the case that somebody had a bad intention, like, let's build the worst systems that we can. Yay, hooray, it will be so great idea. No, usually the intention is good, but I also understand that sometimes it's also hard to reverse this decision. But from other side, it's also sometimes leading to systems that are totally unmaintainable. And, well, even I can say that rewriting is the only way to redo something about that.
It's just counterintuitive, because you think that splitting things would make things decoupled, but it's not really the case. It depends on how you communicate, really.
Yeah. So basically, it's all about splitting things that are coherent. So if you are splitting things that are coherent, you're just ending up with a lot of accidental complexity. And it's pretty bad. And I think it's also partially the reason from where some people see some asynchronous or event-driven architecture as anti-pattern and over-engineering. Because if you've seen many or a couple projects using some patterns and you always seen that it's overcomplicated, well, it's logical that next time when somebody will suggest you, let's do it asynchronously or let's use event-driven architecture, will be pessimistic, because you've seen that, okay, it was always an over-engineered problem. But again, it wasn't a problem of event-driven architecture. It was probably a problem of applying it in the wrong project. So it's important to keep it in mind. So if you've seen some technique or tool in many places and it was always overcomplicated, it's maybe not problem of this tool. Maybe it's problem of person using this tool, or this person maybe didn't understand this properly. It's a theme that we see in many places, and sometimes it's requiring a lot of effort to convince people that no, it's not because of this tool, it's because of applying it in the hard place. But again, if we are not convincing somebody, it's not our issue at the end. I mean,
there's also not really a strict definition of all those techniques, and depending on the language you use and other technology, it will be a bit different. So that's why it's hard to judge. So wrapping up distributed monoliths, the coupling is the issue here, and asynchronous is not really decoupled by default, because events are also a form of coupling in what we mentioned before, right? So on the one hand, you have this, you public an event and you don't care what happens later. But on the other hand, it is also a kind of contract between you and the consumers. So it's, okay, let's say you have this distributed monolith and you now replace the RPC calls with messages. Is it decoupled? No, not really. It's the same issue, just with different transport.
Yeah.
So it's more about the design of the communication, not really the async or sync here.
Because basically you can implement RPC over queue and it will be basically the same. I mean, it doesn't change much if you are calling something directly over HTTP, if you are expecting to have response from your operation.
Yeah, I think Gabriel mentioned this before, that there is one interesting pattern is used by nuts. The call seems to be synchronous, but it's asynchronous under the hood. I'm not sure about this exact one in nuts.
But yeah, I guess that it may be about this something that Celery supports. So basically, it's basically doing RPC over queue. We also have
this is a weird hybrid approach when you can do synchronous over message broker. Can work sometimes.
It has some use cases, obviously, but well, it's not really asynchronous. We also have it in Watermule, so we have the request reply component. But again, it's not really fully asynchronous. So it's nice because you can have some response to know if something was successful, and if you're no longer listening, it will be processed anyway. Not like with request, because if your request data is originating, let's say, originating request, and it's calling everything later, and this request will be cancelled. So if you're handling context cancellation properly, everything else should be killed basically. So it should be kind of rolled back in all requests. But yeah, if you're doing RPC over queue, it will be done anyway. There are some cases when it makes sense, but
maybe one promise here is that you use one platform for all communication. So it sounds good on paper. Like, we don't need RPC because you can just do everything over messages. Maybe it's a good idea. I don't know, but
it's tricky because if you have a request and you would like to, for example, insert something in the database, and your request was cancelled, and this cancellation is not propagating because the cancellation is not propagated to the queue.
Yeah.
So it can lead to some strange inconsistencies because you killed the request. So expect that it should be not written, but it's somewhere later going through the queue. So it will be done anyway. And it can lead to some strange state where you don't know what really happened.
I would summarize it as messages behave differently from requests most of the time. So if you use one as the other, it can work, but you can have some weird edge cases down the line because it's just a different method of communication. So I would be careful with this. Okay, and any more anti-patterns?
So I have two connected anti-patterns here. So it's the first one is using no message ordering. So it's maybe not anti-pattern, but it's something to watch out because in many systems you need to have some way of ordering your messages. So let's imagine that you have event for subscriber subscribed and subscriber unsubscribed. And the problem is if you not order them properly and build some read model based on them, and they will be received out of the order, you may unsubscribe person that was not subscribed yet if the unsubscribe event will arrive first, because it can if it's not ordered. And later you will have subscribed event that should be.
Yeah, that's one of the things you learn when you first start using messages. Those weird behaviors that seem simple at first.
Yeah, and well, the simple solution may be let's just order every message and just have everything ordered. And yeah, it sounds like a pretty good idea, but sometimes it may work. But it have also one big downside, at least. I would say two big downsides. So the first one is performance. So basically, performance of processing those messages will be limited to how fast you are often to process them. And basically, they will be processed one by one. And if operations will be slower, it will just start to pile and you will be not able to process.
Or block your all processing of all messages.
And the second thing that I believe is worse is that if any of messages will spin, it will block all other messages. And it's pretty bad because it's killing all the advantages of asynchronous architecture in terms of stability.
Yeah, on one hand, it can help you not care about ordering, which seems like a nice idea. Yeah, but if you make it too wide, then it can be also an issue. There's a lot of things to consider here. So it's hard to give someone solution, right? So much depends on the domain and the system design. Sometimes you can get away with no ordering, but you can use something like a version. Or I remember one system where we didn't have ordering at all because all events updated different parts of our module.
And I think it was also so the problem here where we're using Google Cloud PubSub and it didn't support ordering at this point also.
Mm-hmm. Yeah, we can kind of get away with it, but I remember we actually used times for solving some conflicts, so it's also not ideal.
Yeah,
depending on timestamps is controversial.
It's hard to synchronize. Yeah. I think in some places where it was possible, we've been using versions. So basically, every event was that within aggregate. Let's say that. So within the say transactional boundary, so where we need to keep ordering, had an incremental version. So if we received event that was out of order, we've been rejecting that, or in some cases we've seen that we received newer price, for example. We received older price and we already stored the newer, so we just can ignore older. But the downside is that you need to support it in custom way for everything. So
not super complex, but something to consider.
But nice to have it out of the box. So for example, Google PubSub have ordering keys, Kafka have partitioning. So there are message brokers that just have it out of box, and you don't need to think about that later, basically.
Maybe we can talk about a bit more about this in the next episode.
Yeah. I guess that's I think ordering is probably even something that it can be just entire episode about that, because this is pretty, maybe not complex, but it has many different use cases that it's good to know about, because in many cases you should approach it differently. Often you don't need to care that much. You can choose something simple and it's fine, but it depends on a lot on scalability requirements let's say resilience.
The balance is difficult.
Yeah,
it's easy to do no ordering or ordering by every message, but something in the middle, you have to consider many factors.
Yeah, but TLDR, I would say it's try to do as narrow ordering as you can. So for example, try to do some subset of events for one customer maybe, or you need to basically analyze where this ordering matters, and based on that, do really narrow ordering, and it will work, basically.
There's one thing that's similar between async and sync, and I think it's API design. So, with synchronous approach, you have some kind of contract in how your API works. If it's a REST API, you can have some open API document. With gRPC, probably protobuf schema.
Yeah, so I see that Gabriel asked about that. So what we are usually using is protobuf, because you can marshal it later to at least two formats. So usually we're using JSON as a transport format because it's easier to debug. But if you care about performance and the size of message, you can use protobuf, so it will be a bit smaller and faster. And you can also convert it to multiple programming languages, and also it's nicely support the versioning of fields.
There's the cloud events schema, I think. We didn't use that yet. Protobuf usually does the job. But yeah, the point is you need to follow similar ideas for both sync and async here. So if your event schema or your API schema is your contract, so you have to make sure there are no breaking changes, and the API is stable, and probably do some versioning if you need to do breaking changes. So we sometimes have events with version in the name, like v1, just to anticipate it. Not always needed, but sometimes useful.
Yeah, and it's also worth mentioning that many message brokers are supporting some kind of schema registry out of the box. So those message brokers can validate the schema for you. So, for example, Kafka have it. I think Google Cloud PubSub have it. I think it's also worth mentioning that some companies are using Avro for that. I think we didn't use that, but I know that it's often used in some companies. But I think, I guess that it's more in Java world. I think in Go world, more gRPC is in use, at least from our
Protobuf.
Protobuf, yeah. Protobuf is more used in our bubble.
It's pretty nice. And as a plus in Go, generated code is quite popular choice, and it works pretty well with Protobuf as well. Yeah, shall we move to the final question? What to choose?
Yeah, unfortunately, it's as you heard. So there are really many
Factors to consider.
Yes,
And the balance is the hardest part, as always. There is no silver bullet, so you have to figure out what balance means for you. It's a bit like the CAP theorem in databases, right? So you have consistency versus availability, and you have to pick one.
Yeah. So in async system, you basically are sacrificing consistency, but you have better availability.
You have eventual consistency, but that's it.
But it's eventual.
So what should we choose? What do you think?
So I think to give you some simple algorithm, maybe. So if you're in doubt, you can always start with Synchronous. So I would say that in many cases, it will be a good starting point. In many cases, using async by default may be maybe not over engineering, but maybe not needed at the beginning. And if you have infrastructure already in place, switching something from async to sync, it may be not that big difference as long as you didn't do any strange thing. And it's especially simple if you are using clean architecture, because you should have some application layer entry point to your application. So basically calling in from RPC or event handler or something, it can be pretty simple change. Of course, it depends a lot on the use case, but again, it's if you're in that. If in some cases you may be just sure, like you're calling some external system and you know that it's not stable, do it synchronously. You have some critical flow that will know that you know that it need to be working. You need to send some external data, do it asynchronously. Again, I'm saying more about cases that you are not sure.
Sometimes it's a product decision as well. If something can happen in the background. And sometimes it's tricky because in the background can mean a second later or 10 seconds later. So it's also takes some skill to be able to talk to whoever your stakeholder is, whoever is responsible for the product, to understand if it's fine to do it in an asynchronous way. Which means most often it will show up in the UI right after, but sometimes it will not after a few minutes maybe. So that's also counterintuitive. Like why would you talk with your product owner about sync versus async architecture? Sometimes it makes sense. And probably it's good to watch out for the extremes as always. Right, so not everything can be handled by synchronous architecture, as you mentioned. There are some hard limits where more complex systems just won't be able to do it. But as you said, sometimes doing everything over messages can be also over engineering. So if you ever consider doing everything one way, probably you need some balance That's usually the clear sign.
And if you maybe didn't work in a system that required building asynchronous architecture, it's fine. But anyway, I would recommend to check out how you can do that, because it's just know what tools you have available. So if you have a problem that will require asynchronous architecture approach, you'll just know, okay, I have tool for that, it fits here, and I can use that. So you will not need to learn it when you have this problem, because it may be just too late.
Sometimes a hybrid approach may be fine. One is what we mentioned before, the RPC over messages. A bit unusual, but maybe it fits some use cases. Something else that comes to my mind is CQRS here. So TLDR, it is a pattern where you split your controller functions, let's say, into commands that change the system and queries that fetch the data. Super short definition. So don't dive too deep into it. But the interesting thing about it is that it gives you this extra structure in your code, commands and queries, so they're separate. And then it can make mixing them and how you call them a bit more intuitive. Because queries are usually synchronous. Someone's waiting for the data, that makes sense. And commands can be either. So it can give you this mental framework to decide how to mix sync and async in one project.
I think it's interesting, the CQRS example, that it's a good example of technique that people really misunderstood, because for many people, if they hear CQRS, it's immediately, asynchronous. But no, CQRS is totally not about that.
Or second database.
Yeah. So it's totally misunderstanding of this pattern. Again, we'll add to materials our article about CQRS, because we've been covering that. Miłosz also did a really nice presentation about that, so I think we can also put it to the materials.
Yeah,
it's important to mention it over and over. CQRS is not about doing things asynchronously. It's some implementation, it's worked nicely, but you can do CQRS with just doing everything synchronously. And it's nice because if you are using CQRS in a proper way, so when commands are not really returning stuff, you can convert it to asynchronous architecture really easily, because just it should not really depend that much on having the feedback from the command.
It helps if you don't have these mixed functions that change the state and also return data. That can be more tricky to decide what to do with them.
Yeah, and it also doesn't require some super big overhead, because this is also something that we heard from many people, like, CQRS, it requires so much effort. But no, it's just a matter of, instead of having some super big application services with everything, just have multiple little services with commands instead of arguments, and commands that doesn't return stuff. And that's it. And you have the basic CQRS implementation in your project. And you can put it into your CV. So yeah, I already mentioned also the migration. So CQRS helps with that, but you can also get some hybrid approach, because often at the beginning of the project, some endpoint can be synchronous, but with time, more and more stuff is added to that. We have actually a good example in our trainings platform. So we have webhooks from our payment provider about information that somebody bought our training. And at the beginning, it was pretty simple, just adding, somebody has training. But now it have a lot of stuff, and we need to actually convert it to asynchronous, to using events. But now it's probably doing 5 things, and sometimes some of those things are failing because it's just doing a lot of that. But again, at the beginning, it didn't make sense to do it asynchronously because it was pretty lightweight. But with time, you can convert that, and you can even start with still having synchronous endpoint and with emitting some internal event or command and just cutting it part by part. If it's some internal logic, you can at the end maybe just remove this endpoint and say the team that is calling this endpoint, you can now just emit an event. or the opposite. So for example, if you have a problem with data quality and other team is not taking responsibility of that, introduce endpoint instead of event and say, if you will not respond to that this is valid, sorry, you need to provide us a valid event and just agree what data should be in this endpoint to make everybody happy.
And speaking of code structure, maybe one more thing that can help is layered architecture or clean architecture or hexagonal or whatever you want to call it. But if you place the logic in some isolated place in your code, and then have two entry points that are either messages or RPC or HTTP, it's super easy to switch between how you call the handler, right? Because you have just two entry points that do nothing else, just map the request to your internal structure, and it makes super easy to migrate as well.
And it's happening, I would say, because it's often argument in clean architecture, like, okay, in clean architecture, you are separating database, you can switch it off or whatever. It doesn't happen often. But changing things from synchronous and asynchronous actually can happen quite often.
Or just do both at the same time. You can have some logic that can be executed synchronously or asynchronously by message. And if you use layered approach, it's super easy to do.
Yeah, and it happens pretty often because database, again, you are not changing it very often, but changing things from synchronous to asynchronous or vice versa, the first I think it's happening more often, but it's happening often because, again, just operations are starting to be bigger and bigger. You start to have more and more teams. Your product is growing. This is hopefully what's happening. And in this case, it's just making your job easier and saving a lot of your time. So it's, I think, a great investment that is not mentioned that often.
Yeah. Okay, maybe as a finishing point, we can talk about reducing this accidental complexity that comes with starting with messaging. Because once you start, there's a lot of topics to grasp. We talk about some today, but it's not really an episode about event-driven architecture, only the comparison of async and sync. So one idea might be to start with some apps that you already have, which is probably SQL database. I probably have some Postgres or MySQL running around, and you can actually have a pretty simple PubSub running on it. That should be good enough for most use cases. Or you can use a cloud-based PubSub. It's at least means you don't need to maintain the infrastructure, which can also be a complex task sometimes with high availability in place and all this.
Yeah, but I think Postgres is a great starting point, and it can handle much more than you think. I actually have some idea about one article that maybe we can show how far away we can push Postgres-based PubSub, because I'm pretty sure that we can push it pretty far away. But let's see.
Yeah, unless you want some complex topology. For starting out, it's a great way to start. And another way may be using a high-level library that abstracts away some of the concepts for you. So, for example, Robert mentioned earlier Watermill, which we maintain in Go. I'm not sure about other languages. I think there's something similar in Python. Probably in every other language there should be something like that. Because you probably don't want to deal with all the the protocol of the infrastructure you use, all the low-level details, so you can focus on the high-level, publishing and subscribing to messages.
And yeah, it's pretty easy to mess something with that. So lose message or make some really subtle bugs. So we're creating Watermill already for a couple years, and you'll be surprised how many little quirks you can have in every PubSub. And it's very hard to debug at the end because you may just be losing one message for 1 million messages, and it's very problematic in systems. So yeah, it's good if somebody already did it for you. If, for example, you don't use Go, we'll recommend to use Go, but if you can't use Go, you can always even look on our SQL implementation and see and inspire by our queries.
Just use Go.
Oh yeah,
the best idea. Yeah, but it's not that complex in the end. But there are also some quirks, so it's better if you don't reinvent the wheel, because it took us some time and I think 4 major versions to arrive at where the SQL implementation is right now. So many edge cases. So if you like to learn more about async architecture and event-driven architecture in particular, we have Go event-driven training that's the site is open for the next 2 weeks, starting from today. So you can learn those concepts in a more hands-on way, solving exercises.
Yeah, so if you are interested in learning that, you are actually pretty lucky because we're running this training twice a year. So if you are listening it later, so it may be already not open, but again, it will be open in next
If you listen to it later, you can join the waiting list and wait for the next sale. We run it as a cohort, so everyone learns together. And yeah, you can just Google Go Event Driven, or we will put a link in the notes.
We have pretty good SEO, so it should be on the top of the list when you will Google Go Event Driven.
Okay. Before we move to the Q&A.
Yeah, definitely. Oh, okay, so Dima mentioned that naming always matters. Yeah, so definitely it matters more often than you will think, but yeah.
Okay, so Gabriel shared more about that events should be facts that already happened in the system, what we talked about. It provides many advantages as states can be recreated from events. Yeah, that's one of the things we didn't mention. It's super useful, so you can have this event log somewhere in your system and then reply those events to do whatever you want.
Yeah, and in other words, have event sourcing, but event sourcing is not asynchronous. I mean, event sourcing can be asynchronous, but it can be synchronous as well. So I would say that it's synchronous by default. But yeah, it's probably a nice topic for other episodes. So we mentioned already financial systems in couple places, and event sourcing is actually quite great for this kind of system when you need to have audit by the law, or you need to have audit because you would like to understand how you ended up with some state.
So Gabriel also mentioned this dependency matrix of events based on types could be help in an organization. I think I said something like, I wonder if there is ready software for this. I think event catalog, there was something like that. But we didn't use anything that we could use across teams. And I mean, place where you can just go and see which team uses what. Because it needs to integrate with your code, I guess, ideally, if you don't want to keep it up to date over time, which can be manual effort. So it sounds like a challenge to do it for any language you use. And if we find something like that, we'll let you know.
So also Gabriel mentioned that there is a nice chapter about event storming in learning domain-driven design from O'Reilly. I didn't read this one. I'm not sure if you had chance.
I have it on my shelf. Still waiting.
TBD. Maybe this summer.
But everything about event storming, I think you can recommend right away.
Yep, definitely. Yeah, I think even storming was one of the biggest game changers for working with some more complex projects and collaborating with some multiple stakeholders.
Also not super complex to learn.
Agreed.
But you have to be willing to talk to people.
Ooh.
Can be controversial in tech teams, sadly. Ordering is probably not needed if you have a good state machine, which guarantees the state of aggregates. It sounds to me connected to event sourcing again, right? If you build aggregates,
or the thing that we have with versioning. So
yeah,
that's true. You can implement that, but from other side, if you also do it properly from message broker perspective, it can simplify also a lot because you can just listen to event and don't care about that. So and we have been able to compare migrating to that and ordering, at least in our case, really help to simplify it a bit. Because I think it's good because if it's done properly, it works out of the box, so kind of out of the box, let's say, and it's harder to make mistake when you need to remember about something. So, but you can also implement universal state machine that can handle that, but universal things that are implemented by you often may have some challenges.
But you can see how many approaches there are to ordering. It's pretty long topic. You have to consider many approaches. So thanks for mentioning this one.
Yeah, so Gabriel will have monopoly on our chat today, almost.
Thank you for contributing. You are the third author today.
Maybe I think at some point we should, try to also share the link to join with us. That would be cool.
Yeah.
Risky, but cool. So Gabriel also recommend reactive manifesto, which is nice definition of reactive systems. I remember reading that probably long time ago.
Yeah, so, same.
Recommend checking, yeah.
I feel like ignorant at the moment, sorry.
Yeah, in Scala there is a logom framework, which was nice. Akka is under the hood. Maybe. We are not Scala guys.
Yeah, so it's good that there is similar software, so you don't need to understand everything, what's going on, which can also be tricky because sometimes you may lose some, you may not understand something correctly, like the configuration of some pops up. But to start out, it's super important to have these high-level concepts in place. You just publish a message, subscribe to a message, and don't care about what the bytes do underneath.
Yeah. And also Gabriel mentioned that it's Akka under the hood. So it would be actually interesting to see how actor model is going up. I mean, if it's visible or not. So personally, I'm not a big fan of actor model. I mean, I don't like the mental model of actor model. So event driven fits in my head much better because you can get event storming and it maps one-to-one in some way. And actor model for me is a bit more like magic mental mapping that you need to do. And I don't know, what's your opinion on that? But
yeah, I didn't use it much except for playing a bit with Elixir. So yeah, I can't say much. Maybe you can do another episode sometimes about comparison.
Fortunately, Gabriel said that, but I go much more. Hooray!
Way to go! Woo. Okay.
Cool. So a couple more seconds for more questions.
Okay. While we wait, it's the time you should hit the subscribe button and rate our show on the post.
Let's wait. Please click this button. You didn't click yet. I see your screen. Okay, thank you. So also now 5-star review. Please write something nice. We'll wait here. We have time.
Yeah, and instead of the YouTube subscribe, there's even better subscribe button on our website where you can join our newsletter. So then you won't miss the updates from us.
Plus, you'll also receive notification about the episode notes. So there is entire transcript. We're linking to all sources that we're mentioning here, like Watermule, like ebook about event storming, and about a couple more things that we mentioned, and I don't remember now. But yeah, it will be all in materials for this episode. Plus, also, if you release any new articles on the blog, you'll be notified. So I think it's pretty cool because, yeah, I mentioned, for example, article about SSC that we have on our blog. So yeah, we're trying to share a lot of quality stuff that will be useful for you. Something more, Miłosz?
No, I think we have no more questions. Thank you, everyone.
Just a reminder. So Go Event Driven available for next 2 weeks. Later, you need to wait for half year. So don't wait for the last hour because
better to join now.
We are starting and you will need to wait.
Cool. Thank you, everyone, for joining us. Thank you, Robert, for joining me.
Oh, thank you, everyone. Thank you, Miłosz. And see you in 2 weeks. And we'll talk about
event-driven architecture more in depth than today.
Sounds like a good plan. So see you in 2 weeks. Thank you very much.
Bye-bye.